Hello, so today we are going to do this problem, part of Leetcode July challenge, number of matching subsequences. So the problem says that we get a string S and an array of words, and we want to return the number of words that are subsequences of S, right? So a subsequence is, of course, a set of indices, the letters in a word match a set of characters in S, such that those characters are in increasing order. So basically, a string from the original string with some characters deleted without changing the order. So for example, Ace here is a subsequence of this string because we have A, C, E. So you can see they are in the right order. So that's what we are looking for. We are looking for the number of words that are subsequences. If we take a look at this example, this is the string, these are the words. So which ones are subsequences? If we look, A is a subsequence, right? And then ACD, right, is a subsequence as well. And also ACE, ACE. Okay, so 3, we return 3. So that's the main idea. Now, one thing to pay attention to is in the constraint here, S can be really large. The length of S can be really large. The number of words is also is relatively smaller, and the length of words is small, 50, and we have only lower English letters. Yeah, so just pay attention here that if we do something that traverses S twice, this is going to be really big. Yeah, so let's see how we can solve this problem. Okay, so let's see how we can solve this. So the main idea here is similar to Trie's, where if you are doing string matching there, you have to traverse for each prefix. So if you are looking for, let's say, ACE, you will find A, and then now you are looking for CA, and you will continue looking for the rest of the string. So that's just like a hint of the idea, but we are not going to use a try actually. So let's see how we'll do this. Okay, so what we can do here is use a dictionary of prefixes for words. And the idea behind this is so that we can do, basically if you have ACE and you have ACD and maybe and A, like in this example here, well, there is no use in going through every, and we know our string is this. So we know we get a match of A. It's not really useful to do it word by word. So we will do it 3 times. Instead, if we knew that we have 3 words like this here that start with A, then for all 3, we know we found A already. We can move on and check these, right, immediately. And you can see here, for example, these also the to have CC. So we know that we have a C here, right? So there is no use in doing them both separately. We can do it both at once, right? So that's the main idea. And so how do we do this? Well, we can just, at the start, create a word dictionary of basically prefix letter to the words that start with that letter. So what this would mean for our example here is that we will have, well, A, the words that start with A are A, ACD, and ACE, right? And for B, the words that start with it are just BB, right? And for the other letters, nothing. At least nothing starts with it. And so we put empty list. So once we have this dictionary, we can just traverse S, right? So for every C in S, what we'll do is check, is this S equal to one of the prefixes in the dictionary? So to do that, since this is the key, we can just do word dict for the letter, right? And from this, we will get these words, right? And so for these words, we know we matched the first character, so we can proceed to the next one. So how do we proceed with the next one? We just, this time, insert in word dict. We would insert CD and CE, right? And then here we are done, so we need to count that we found a match here because it's done. So what that would mean here is that we'll traverse, let's call these maybe E or something. So we'll traverse E. And if the length of the word was 1 and we just found a match for that 1, we are done. So if the length is 1, then we need to count it because this is a match. So we need to increase our count. Otherwise, what we want to do is add in our dictionary these without this first prefix, right? And so to do that, what we can do is just in our word dictionary, we want to add the word from 1 on because we found a match for the first letter. And what are we going to add? We are going to add the word again. So, sorry, actually, here we want it to be just for C to map to these two. So this would mean the first character. So the character is position 1, which is the next after 0. We want to append the word starting from 1. What this means for our example here is that we will insert C with basically CD and CE, right? CD and CE. Okay, and the rest will remain unchanged in our word dict map. The other thing is that this A here, we already processed it, right? And so we need to set it to empty list now. So we need to set A to empty list. And we actually need to do this before doing this processing because what if we had words that are like AAB, right? So we don't want to here put the character and then after that like erase it with this empty list. So we want to do that here. We want to do something like word dict of C now becomes an empty list, right? Because we are going to process it here and we already put it in this placeholder. And so now with these, we know now our word dict state is A here, empty list, and B only is going to map to just BB, right? So I'll just do the rest of the logic a little bit. So this is what we had here. And the rest of them are just map to empty string, empty list. And so now we do the logic again, and we pick the next character in S, which is, S here is A, B, C, D, E. And so we process B now. And so now we check BB, right? And so we know we haven't reached, the length is not 1, the length is 2, so we don't need to go here, we need to continue. And so what we would do here is we processed B and we know it exists. So now we are going to make this an empty list first, right? From this here. And then we are going to add the remaining portion of BB, right? So we found this B. Now we are done. We need to put B so that we can process the next word, okay? And now we move to the next character. So you can see here, because B occurs only once and we already processed it, we won't find it again, so this would never get a match. And now we are at C, so we have the words that start with C here, and so we need to process these. Each of them is of length 2, so we don't have a match yet. And so what this would mean is that for these two, CD and CE, we found a match for C, so we need to add D and E. And so this here will become this. And we will move on to the next iteration now. Actually, let me just go back here a little bit. So these will become D and E. They don't start with C, right? So C is going to become empty. And we need to have D, a new one for D here, for words that start with D. So that's D. And the new one for words that start with E. So this is E here. Okay? And now we move the character again, and now we have D. And we find a match for D here, so we increase our count, which was 1 before, now it becomes 2. And we make this empty, and now we are done. We go to the next character, which is E, and we find that we have a word that starts with E and has a length of 1, so we can increment our counter here to 3. And now we finished traversing S, so we won't find any matches anymore, and so we are done. So you can see here, by just traversing E and using this dictionary, we were able to do all of them in parallel, all of the words in parallel. So that's the main idea of this solution here. Yeah, so let's code this up and make sure it passes. Okay, so let's write the implementation for this. So we need our word dictionary that contains the mapping from the first string, the first character, to the words that start with that character. So this is going to be a dictionary in Python, or a map. So default dict, and we want to have a list as the default value so that characters that don't exist have an empty list. And now we will go through the words. And for each word, we will map the first character, and we'll add the entire word that starts with that first character, okay? And now we will initialize our counter, and we need to traverse S. And each time we grab the words that start with that S, right? So with that character, so this is C, we can name it whatever you want here. Let's name it like rest or something. And now we need to say that we are processing this rest here, so we don't want to process it again, so we need to set it to empty list. And now we'll go through the words in this rest here. So remember, these are the ones that we found the match for their first character, so we need to move on to the next, to the rest of the word. And so if that word had length just 1, which means that here this is equal to 1. So let's say in the case that we saw earlier with A, we have A in S, and the length of the word was just A. So actually this is maybe, let's call it something else. Then rest makes it seem like it starts with 1. So maybe just expected or something. So if the length was 1, that means we found a match, we are done, so we can increment our counter. Otherwise, we need to add the rest of the word to our dictionary. So this would mean that word dict. So for our case, the case where we had, let's say, ACE, right? We want to add a new word that starts with S, so mapping S to a list that has CE, right? So how to find S? S is the letter at position 1, and so that's W of 1, and we want to append the word, but starting from 1, so we want to append here. And so that would mean W starting from 1. And that's pretty much it, and we want to return the number of words that we found. In terms of time complexity, this is here is O of the length of S, this loop. Let's call it big S, and here each time we'll go through at most the number of words, right? So W. And in terms of space here, we are using this here, which is the length of words. I think squared because it's each character. Yeah, but that's pretty much it for this problem. So let's run it. And let's submit. Okay, so that passes test cases. Yeah, so that's pretty much it. Thanks for watching, and if you liked this video, please like and subscribe, and see you on the next one. Bye.